All right, let's dive in. Today, we're not just solving a coding problem. Oh no, we're planning a heist. This is one of those classic puzzles that really makes you think like a master thief, where one tiny little twist changes the entire game. So let's gear up and figure out how to pull off the perfect score. Okay, first things first. Every great heist needs a clear objective and a very specific set of rules. Your mission, should you choose to accept it, is to get away with the maximum amount of cash from let's say, a very unique neighborhood. Yep, you heard me. For the next few minutes, you're not a developer, you're not a student, you are a professional robber. And you're planning a single night's work on a street lined with houses, and every single one is filled with a different amount of cash. But there's always a catch, right? And this one is a biggie. The houses have this interconnected security system. So if you hit two houses that are side by side on the same night, bam, alarms go off, the cops are on their way, and it is game over. This one rule, this is the key to everything. Okay, so before we jump into the really tricky part, let's do a little warm-up. Imagine the houses are just in a nice, simple, straight line. Think of this as the tutorial level. This is basically the house robber eye problem, and trust me, you're going to want to nail this down first. So, as you're walking down the street, you get to each house and you've got a choice to make. It's pretty simple, really. Option 1, you rob this house. If you do that, you pocket the cash, but because of the rule, you can't have robbed the house right before it. So you add this house's money to whatever your best haul was from 2 houses ago. Or there's option 2. You play it safe. You skip this house. That just means you carry over the maximum loot you had from the house you just passed. And that's it. That's the secret sauce. By just making that simple, most profitable choice, house by house by house, you build your way up to the absolute maximum amount of cash you can get from the whole street. No alarms, all profit. Simple and very, very effective. All right, you've got the street down pat. Easy money, right? Well, now for the real challenge. The neighborhood we're hitting tonight, it's not a straight line. It's a circle. And this, my friends, is where things get interesting, and that simple rule gets a whole lot more complicated. So let's just break down what that really means. On our simple street, the first house and the last house might as well be in different cities. They don't know each other, they don't care about each other, but now, in this circular layout, boom, they're neighbors. The last house loops right back around to the first, and that means they're connected by that same pesky security system. So what's the big deal? I mean, it's just one little change, right? Why does connecting the first and last house completely wreck our simple step-by-step strategy? What breaks? Here's the cool part. The solution isn't some crazy new, super complicated algorithm. It's all about one key insight, a single aha moment that lets us solve this new hard problem using the exact same simple tool we already built. And that insight comes from the direct consequence of the circle. It's that the first house and the last house are now linked. Their fates are intertwined because of that security system. They are, for all intents and purposes, adjacent. And this is it. This is the key that unlocks the whole thing. You cannot, I repeat, cannot rob both the first house and the last house in the same night. They are mutually exclusive. You can hit one, or you can hit the other, or you can hit neither, but you absolutely cannot hit both. And once you realize that, everything just clicks into place. See, if we can't rob both, then any possible plan that works has to be one of two things. Either it's a plan that ignores the last house completely, or it's a plan that ignores the first house completely. And what does that sound like? Each of those is just a simple, straight-line robbery problem, the very thing we already know how to solve perfectly. Okay, so here's the master plan. It's brilliant in its simplicity. We're not going to try to solve this complicated circle problem in one go. No way. Instead, we're going to plan 2 separate, much simpler heists, and then we're just going to pick the one that pays more. So here's plan A. We just pretend the last house doesn't exist. We mentally block it out. By doing that, we break the circle. And what are we left with? A simple straight line of houses from the first one to the second to last one. And we know exactly how to get the max loot from that. Then we run plan B. You can probably guess what this is. We do the exact opposite. This time, we pretend the first house isn't there. Again, the circle is broken. We get another simple, straight line problem, this time from house number 2 all the way to the end. And we solve that one too. Let's make this super concrete with an example. Say the houses have this much cash. 1, 2, 3, 1. Okay, for plan A, we ignore that last house with a 1, so we're just looking at 1, 2, 3. What's the best we can do? Well, we can't rob the 1 and the 2 together, so we rob the 1 and the 3. That gives us a total of 4. Now for plan B, we ignore the first house, so we're looking at 2, 3, 1. What's the play here? We can't rob the 2 and 3, so we'll rob the 2 and the 1. That gets us 3. So plan A gets us 4, plan B gets us 3. Which one do we choose? We take the money and run. We go with the bigger haul, which is 4. That's our final answer. And this is what's so cool about this. That whole big idea, this clever strategy of splitting the problem in two, it boils down to one beautiful single line of code. All it's saying is, hey, run our simple robbery function on the list of houses, but skip the last one. Then run it again, but this time skip the first one. And whatever the bigger number is between those two heists, that's our answer. It's just perfect. So what's the big takeaway here, besides how to digitally rob houses? Think about it. The key to cracking this really tricky-seeming circular problem wasn't some new, super advanced technique. It was about stepping back and finding the right perspective. The perspective that showed us this one big, complex problem was actually just two simple problems we already had the solution for, just kind of hiding in disguise. And that really makes you wonder, right? How many other complex problems out there are just simple problems in disguise, waiting